This is the ROS Developers Podcast, episode 87.
The ROS Developers Podcast, the ROS Developers. The ROS Developers Podcast, the ROS Developers.
Hello, ROS developers, and welcome to the ROS Developers Podcast, the podcast that gives you insights from the experts about how to program your robots with ROS. This is Ricardo from The Construct, and today we are going to talk about how we can optimize Linux distribution for embedded computers, and especially how to use that with ROS. And then I would like to dedicate this episode to all those ROS developers out there that are using embedded computers to control the ROS robots, you know. That's not very common in the environment that I'm moving myself. Usually we use a normal PC to control that. But I know that there are a lot of ROS developers there using embedded. So I think that this episode is going to be very interesting for you. But before going into that, let me talk to you about the academy that we have at the Construct, which is called the Robot Ignite Academy, you know, right? And this week, because I'm recording on the week that we have released the Robotics Remote Real Robot Lab, but you're going to listen that in 2 weeks after that, so it's not this week that we have released. So let me tell you about Robotics. It's a ROS-based remote real robot lab, 24/7 running. So you can connect to our lab, which is a real robot lab with a Turtlebot 3 robot that runs ROS, and you can connect from your location and do your experiments on the real robot. We provide a complete simulation of the environment, which is, you can see here on this image. And it's the simulation that mimics the same thing as the real thing. So as you can see on this other image, if you are on the podcast listening only, okay, so you can go and watch the YouTube video and see the differences. So there is, on the bottom, there is the real environment, and then at the top is the simulation of that environment. So with Robotics, you can connect from anywhere using any computer. Don't have to install anything, and then you can test in real time your algorithms in a ROS robot and practice and learn a lot by doing practice, right? This is cool, right? Okay, so I think that I hope that you are going to like and you are going to use it a lot. It's there. Go and check it. I will put a link below on the show notes of the podcast. And now is the time that we go into the interview of today. And today we are going to interview Raul Muñoz, who is the community engineer at Foundries.io. Raul, welcome to the podcast. And can you explain us what is this title about community engineer?
Absolutely, Ricardo. Thank you very much for having me here today. And yeah, community engineer is a role that I used to help customers to get started with our platform. I have to go to events to talk and explain our technology. It's more like people that understand the technology, understand about the technical aspects of the technology, and also go out and explain to people how to use, creating demos and creating podcasts like this one and things like that. So yeah, I'm doing a little bit of both sales and engineering, and that's my role is about.
Okay, because I was going to tell you, well, so what you are explaining looks more like a sales or public relations things, but I have seen you managing the computers and the robots and so on. So I know that you are an engineer in the inside, so that you know about your stuff. So it's a combination of both things, right?
Yeah, absolutely. Yeah, I have started my career doing embedded development with embedded Linux, but then I moved to another company where I was field application engineer, and I'm very proud of that because in Brazil, where I'm from, on that time, like 10 years ago, there wasn't too many companies doing embedded Linux here. So with that company, I was able to use the 6 years in that company helping everyone to get started with Linux, understanding how to design their own embedded device, and all of that with Linux. And then in the beginning of this year, I moved to Founders, where I'm able to not help just in Brazil, but also around the world. So it's a very cool position right now, and it's a very cool company and technology.
And what do you do now at Foundry? So what is the goal of Foundries, your company?
Yeah, that's a good question. So Foundries was born 3 years ago, and it's a spin-off from a company called Linaro. I don't know if the people listening is familiar with linaro.org, but Linaro was a company founded like 10 years ago with the goal of helping all the ARM customers to get a better support on the open source ecosystem. So basically, if you remember, like some time ago, all the ARM customers like NXP, TI, Qualcomm, they were like fighting and trying to work in the same tasks. And then how ARM found to solve this problem was creating Linaro. And Linaro is where all these companies work together to have a better support for ARM devices in the open source community. And then Founders was born 3 years ago because the first employee of Linaro and the CEO of Linaro left Linaro with the goal of found Founders. And we are trying to solve a very big problem in the embedded industry, which is there is no platform for IoT and edge devices, or there is no platform for any embedded device, let's say. So if we think about mobile, we have Android. If we think about computers, we have Windows. But there is no platform for IoT and edge devices. Okay. And when I say IoT and edge device, it includes also robots out there.
Okay.
So just to complete, like, why there is no platform for IoT and edge device, and it's very obvious the answer. It's because all the IoT and edge devices are different. So all the robots, all the device gateways, everything that is not a computer and a mobile, it's different. Your Alexa, your robot, and they all share the same software core, let's say, And then if we go further, why there is no platform for such device? Because it's different, it's difficult to design such a platform. And I think what Founders is designing is something that will really help all the companies doing embedded devices to have a common core where they can take benefits from each other in the core, and they can add their own differentiation on top of it.
Okay, I see. Yeah, like you are trying to unify for all IoT and edge devices to provide a common ground. So basically, you are aiming at designing the windows of IoT, and you are providing based on Linux, I presume, because we are going to talk. Yeah. But I wanted to tell you. So one thing that you make me ring a bell now you make me have an idea. It's about then maybe that's another niche for ROS, actually. So maybe ROS can be this framework that can unite all those IoT devices around there. So take the place from the robots only, but going into other devices and so on. What do you think about that?
Yeah, I think ROS is a very nice. It's exactly the same for robots, because, for example, if you think some times ago, everyone was doing their robot with their own frameworks and their own algorithms, and when they start to create this ROS stack and this community, everyone is taking benefits from the same.
Correct.
But exactly. Of course, ROS is still a software that runs on top of a distribution. Mm-hmm. So it still needs a Linux and a Ubuntu or infrastructure in the base.
Yes.
So we are really focused on this base. And this is why I'm not an expert on ROS, but I'm more like, we can help anyone doing embedded device. So we have customers doing, like I said, public gateways, public Wi-Fi's. We have customers doing measurement and like monitoring real containers in big chips around the world. and we have customer also doing robots that I will mention in the next in the next questions. So we have customer all around the embedded and IoT device, and ROS is of course a stack that could come on top of our platform.
Okay, I see, and that's very good news, because then that means that there is a piece of cake for everyone. So it's not that you are taking, or somebody else is taking the cake for or the pizza, the whole pizza for himself. That's great. And then I think that we have understood your role. We have understood what Foundry is after, and is working on making. And as we will see in a few minutes, because we have a live demo in this podcast, we are going to do a live demo connecting to robots remotely from another country. Actually, where are you based, Raul?
I'm based in Brazil, and the robot is in the UK on my boss' house.
Exactly. And so we are going to see that live here in this podcast. But let's not go fast to that. So summarizing. So what is your role? What is Foundries? And then by searching on your page of Foundries, okay, so what is this thing that you call FoundersFactory?
Yeah, so FoundersFactory is a cloud platform to both reduce the costs and also simplify the way to design an embedded system. So it's a platform where you can development, you can deploy, you can maintain, you can secure your IoT and edge device, and you can also manage all your devices. You can over there update your devices. It's a complete cloud platform helping you to bring the development of an IoT and edge device to the cloud as well. So it's also cool because it's a different approach than you build everything on your PC and having your own server and things like that. So yeah, it's a cloud platform to help you develop your IoT and edge device
and deploy
and maintain and maintain secure. And that's what I was explaining about Founders. What we are trying to solve is this fragmentation of the IoT and edge software industry. So if you are designing an IoT and edge device or a robot, you have to get Ubuntu from somewhere. You have to think about what's the best OTA solution for your device. You have to use ROS. You have to put all these pieces together, and that's very difficult. Yeah. And each company is doing in their own way. There is no standardization. What we are proud to say is that today we have a platform where you can do everything in the same platform. You can develop, you can OTA since day one. If you flash your robot the first day, you can start deploying new images without reflash and things like that. So it really helps developing, deploying, and also maintaining your device.
Maintaining. Okay, great. Then now I have understood about that. Let me see about the other questions. So, and also you have answered my next question, which is, why do we need such a platform for developing for embedded computers? So you have already answered, because it's about creating this kind of standard environment for everyone.
Yeah, I think one thing else that we can say, and I didn't emphasize too much, is this maintaining, how it works, right? Because for today, if you have a robot or a device running any distribution from the vendor, or Ubuntu or any distribution that you just install in your device, who is taking the responsibility of maintaining it up to date? And at Foundries, we believe that the most secure software is the latest software. So even though you are choosing an LTS version of kernel or image, sometimes a vulnerability that
appears,
someone found, takes some time to that vulnerability be supported in the LTS version. Uh-huh. So we really believe that you have to be prepared to run always the latest software in your device. So part of our solution is also to help all this company in the maintenance. And how we do that? We keep moving the Linux micro platform, which is the Linux image that we offer, forward. It doesn't mean that you have to update your robot as frequently as we update, but we say that it can work as an insurance for you. You can have a different branch where you keep moving further your application together with our Linux.
Okay.
But if something happened, or let's say a risk or a vulnerability show up and you see that could affect your robots, you are ready to deploy it in this new version.
Yeah, I see.
And of course, if you want to update more frequently, like whatever you want, 1 month, 2 months, it's also up to you. Get all this maintenance that we do, keeping moving further this Linux micro platform and making it secure for you.
Okay, great. Then now we know better about the need of such platform, and we really understand what's the meaning of that. Then if we talk about robots, what would be the advantages of using Foundries in front of using the normal development systems that we have? Basically, is our local computer, or maybe in some cases they are using some cloud computer also for developing and for. So, what would be some of the advantages? You have already more or less mentioned, but if you can say it now in a structured way.
Yeah, one thing that I didn't mention, because I mentioned quite a lot of other things yet, but one of the things that we think, one of the approach that FoundersFactory is using is the Linux micro platform, the Linux that we offer, supports Docker container. Okay. So of course, there are many different ways to deploy a ROS application, a robot. You can use the Meta ROS and build it with Yocto. You could use Ubuntu with Snaps, or there is many ways to do that. But of course, there is also a Docker, using Docker container as well. And Docker container is very well supported supported on the community. If you go to Docker Hub and you search for ROS, you can see all the ROS versions there ready to be used. And all this container is based on the distributions that is necessary to run ROS. For example, if you want to use like the kinematics, there is like the Ubuntu, correct Ubuntu 16. To run that supported there. 16. And that being said, because we support Docker container, you can easily containerize your ROS application and run on top of a very optimized Linux distribution, which is the Linux micro platform. So like this is where we come together. Like we have some customers using ROS. I saw this customer was really happy because they can customize the distribution, they can change the kernel, they can change the device tree, they can make it special for their robots. And they don't need to worry about having an Ubuntu on top of it, because they can just containerize everything together and update. And also, just to complete, another cool thing about using container is that you can use different containers side by side. So today we have many different possibilities like machine learning, cameras, and sending data to some IoT web server. So you can run each on different containers, and each container doesn't need to have the same, doesn't have the same dependence on each one. So if you are running, let's say an example. Okay. If you are running, let's say, a streaming camera, and you need, let's say, OpenSSL version 2, I don't know, just a guess, and your ROS container needs version 3, you can have in the same device different container with different libraries for both cases. Yes. And when you are running like on a single Ubuntu, you have to somehow hack it and make it work. Or decide you are not going to go one version. Yeah, you are not going to go with that one. Yeah. Okay. Yeah. So, okay. Then, yes. So we have understood now about the different some of the advantages. Okay. So about using this normalized platform or standardized platform for developing, in case that this is for embedded computers. So we are talking here about embedded computers, right? We are not applying this to PCs, standard PCs. Yeah, that's not really right, because our platform, we designed FoundersFactory to support ARM, x86, and also RISC-V. So we created that platform for a multi-architecture. So to be honest, I think of course, some of our customers that's really happy, they are designing on ARM with custom embedded device. And this is where they clearly see the advantage of customizing, of creating the distribution, because their devices are also very teeny. And
they need this optimization. So that's very important. It's going to provide them the real difference, right? If they are able to optimize that, right?
But also, that's also true for x86, for example, because why you need like a such big distribution that when you do apt-get or whatever package manager you use, install many different things that you don't really control, other than have a very optimized distribution, even on your x86 robot. And then you can deploy containers on top of it as you want. So we also have customers using x86. They are really happy with that as well, because they can really optimize and so on and so forth. And and also another thing that is cool about FoundersFactory, our goal is to deliver immutable software for your device. So if you think about how we design it, you build your platform, you build your container, and you create your image, and that image will be deployed in every robot in the same way. So if you are thinking about embedded device like ARM or x86, that's a very cool thing to be done. So if you have 1,000 robots out there, exactly, you will know absolutely what's running on the 1,000 devices. It will be always the same, and we will know every package that's installed and so on and so forth. So
amazing. Yes, amazing. I think that those tools are definitely needed for developing faster and for the next years that we are going to work. So you mentioned about optimizing the x86, so the PC typical computer. And why don't we do that at present? Well, because we don't have that pressure. But I'm pretty sure in the next years, this pressure is going to appear. Why? Because there is a lot of other people that want to build their own companies, own robots, and then it's going to be a real concurrence of different companies trying to provide the same service, the same product. And then when there are competitors, then you have to optimize and you provide a better service. And we don't have yet this year, but it's going to come. And at least that's what I think on that sense. So, so you have explained a lot about the updating and securing the IoT devices. And so can you tell us why that updating and securing the devices is especially so important in robots?
Yeah, absolutely. That's a very good question. So for any device nowadays, the devices are more and more connected to the internet. So if we think like a couple of years ago, the devices were not that much connected to the internet. But
especially robots. Robots. So robots, you bought them and then they were kind of autonomous. They were running everything.
Yeah, and I think that the biggest change is because now we have 4G and 5G coming and so on and so forth. More and more devices are connected to the internet. And that being said, when you are connected to the internet, your risk is really increased quite a lot because you are more vulnerable. More people can access from the cloud your device, can try to access your device. And of course, everyone building a robot know that robots could be danger as well. So if you think a robot like cleaning streets or a robot or let's say a autonomous car or autonomous robot,
or a hospital, a robot on a hospital.
And if someone takes the control of this robot, it could be really dangerous. Or there is, of course, a cost of stop the device of work. And there is also a very high cost if this device cause anyone a risk, or let's say hit someone, or maybe something will happen. And yeah, that being said, also another thing that I like to say about that is if you think about robot companies, there is many startups out there trying to create their first robot with a couple of robots and trying to get investors looking to their companies. So have you ever think about show your investors that you are also caring a lot about security? That might help you to get more investors, because if you show your investors that you are looking hard for security, if you are paying attention on that, there is less risk for something bad happen in the future, and of course their money will be better saved, let's say. So I'm trying to also erasing that flag, like showing that it's also very important to you to show your investors to get more money that you are caring about security. You are looking for that.
And for that you need to be updating, and you need to be having your robot on the latest, as you mentioned at the beginning of the podcast, so you need the robot to have having detected the breaks in security in your system. Then you need to have deployed the solution.
One thing that I didn't mention that we also cover here at Founders is helping customers to do something that we call trust boot. I didn't mention that before.
What is that?
Because we have too many things to say, but trust boot is when you guarantee that your bootloader, your kernel, and your root file system was designed by you. So basically, we sign the bootloader, we save this key inside the chip, and so it will just boot images signed by you. So that's something really cool, because you can do that for x86 and for many ARM devices. It's a hardware feature. You have to choose the correct hardware to perform this kind of thing. But it's really cool because with this feature, you can guarantee that your Linux is the Linux running in your device. So what that means is if someone hack and try to replace something like in the distribution or in the kernel, it will fail. It will not boot. So that's a way to make it more secure. And of course, there are many other things that you have to pay attention to make your device secure. Like you have to be always up to date. Like I said, keep your every software, not just kernel, not just the Linux, but all the software inside your Linux can have vulnerabilities. So you have to always take a look on that and know what you have inside your robot. And also, last but not least, having the possibility to over-the-air update your device. Think about a robot, like 1,000 robots spread in the street. And then for some reason you have a vulnerability and someone is calling you asking for money to solve that. You have to have a very easy way to fast solve that problem. And having a good over-the-air solution, it's the key for that.
Okay, great. Then and now you also mentioned before what the role of ROS in all that and how those enter here. So that question is already answered. But then there is a relation in what you are talking with another product. Well, I would say it's product, but it's another development inside ROS, which is called micro ROS, which is ROS for microcontrollers, for example, running on ARM. And so what is the relation or what is the difference between what you are talking and the micro ROS distribution?
Yeah, like I said before, I'm not an expert on ROS, but as far as I read about micro ROS and ROS, micro ROS is something new that came for microcontrollers. So if you have a microcontroller and you want to have like an Arduino and you want to have a micro ROS running, that was designed for microcontrollers. So FoundersFactory is not working in the microcontroller area yet. We design our solution to focus on those devices, those IoT and edge devices with a microprocessor running Linux. Okay. So and then we are talking about like ROS and ROS2 running on Linux.
Oh, Linux.
So
okay.
that's where we can help you. So if you have any robots, being that x86 or being that an ARM or even a RISC-V, you can come to us and take a look on what we have that we probably will be able to help you.
Okay, that's very clear now because micro ROS has another kernel there, which is the one that is running micro ROS on top of that. and I don't. I think that it comes from Linux also, but I mean, I'm not an expert on micro ROS, but the kernel is not a Linux kernel. It's something especially made because it's a microcontroller and doesn't have any.
Yeah, I think it's
almost
it's very, very optimized. So
exactly.
It can run on very small devices.
Exactly.
Just one cool thing about, just another thing interesting that we have seen an increase during the past years. I don't know if you are familiar with heterogeneous multi-core. So what that means is some processors, some ARM processor come with the main processor that can have like 4 cores, let's say 4 cores, 1 gigahertz, and so on and so forth. And then what they are doing is they are putting together with the chip in the same chip, they are putting some microcontrollers inside of that. So if you see all the NXP IMX8, the IMX7, they have a Linux processor inside and they have a microcontroller in the same chip. Wow. And they share a memory where you can communicate. And that's a cool feature because, for example, our customer is designing all the ROS stack on the Linux, but when they need the real time and something very optimized, they also have this microcontroller beside there, and they can use to do this real time activities like control the motors, the sensors, and things like that. And that maybe could be a way to put the micro ROS in these microcontrollers, but exactly. I'm not sure.
I do think yes that's one of the. I mean, that's possible. That's possible.
Because it's a ARM M4 inside the same chip. So if you have micro ROS supported for ARM M4, you can probably run that beside these processors on these chips.
Cool. I didn't know about that. Okay, then now, so we are sold. So we want to use Foundries for develop FoundersFactory for our robot. So what does our robot need to have or be a structure in order to be able to develop in this environment and then deploy and so on?
Yeah, like I said before, we are here to help any customer doing embedded or IoT and edge devices running Linux. So if you are running Linux or you are planning to run Linux on your device or in your robot, here is where we can help you. Being that an x86 or an ARM, we will be here to help you during the development, deployment, and maintaining your device up to date, and also helping you on secure your device. And yeah, if you are interested to take a look here, we have 30 days free on our website. You can go there and take a look with our reference designs. You can try in any x86. It's very easy to go download an image, having your own factory, and start since day one to over there update your devices.
Okay, so they can do this trial for 30 days, which is where can they find it? At foundries.io?
Yeah, if you go to foundries.io, you can go there. It's a 30 days, no credit card needed. You can go there and try for as you want.
Okay. I will put a link into the show notes. So if you don't know how to spell Foundries, you can find it there. Mm-hmm. Great. Then now that we know all that, I think that this is time that you show us how it works, and we can go to see the demo. So what about the demo that you have prepared right now?
Yeah, one thing that I didn't mention, I started to work with ROS because I saw one customer doing vacuum cleaning for hotels. The name of this customer is MadeBot, it's public. But I saw this success and how they like it, and I started to think that could be interesting also for other ROS people, so other ROS developers. And what I did is we bought a robot called Nairo. It's a very famous robot because it's an open source robot. They are from France, I think.
Yes,
so we bought one. And one of the cool thing is, like I said in the beginning, you can create your own Docker file with the Docker Hub reference, but you can also containerize it, everything you have, and create your own container with you have. So what I did here is I went to their website. They have this image for a Raspberry Pi that it's a Ubuntu image. I took the root file system, I containerized this image, and I just put as a container on FoundersFactory, and then now I can have the robots on top of the same image, the same Ubuntu image that Nairo provides on top of the Linux micro platform. So I still have the possibility, I now have the possibility to over there update the platform, other containers, and so on and so forth with this Nairo image, and I didn't really need to touch anything.
Okay. And now that the robot is prepared in this way, so now it means that it's directly connected to your Foundry's account of development, and then so you can control that robot remotely, or you can update it, and you can you can do whatever you need that we have been talking along the whole podcast. So can we see the robot?
Yeah. We will do a demo right now, so if you are just listening, I will try to explain as much as I can for you to understand as well. But now I'm just sharing my screen as well, so if you are just listening, you have to pay a little bit more attention, and I'll go to the video to take a look on what we have. So this is the FoundersFactory. Basically, what I'm showing here is all the builds that you can do in the clouds for my demo factory. So if you take a look here, there is container builds and platform builds. This is container builds for ARM64, ARM32, x86. And like I said, and just 1 second before let me move back here. And yeah, and this is a platform build. So what's a platform build? It's a Yocto build in the cloud, and it's a Linux micro platform that you can customize. And here it's all the container apps that you can on my factory that I can deploy on my device.
Just a second, Raul, because we have a problem here on the update of the screen. So let me see. So here it is. Yeah, it looks like there is a problem when you are changing from one screen to another. So the screen doesn't get updated here on the recording. So I need to close and restart. So it's done. So now it's done. So we can see your screen.
Yeah. So here so basically what customer will have is they will have 4 private repositories. They can push change to the server. That builds will happen in the cloud. And by the end of this build, if it's successful, you have a target where you can, and basically the target is a description of which software you can run in your device. And also what we have is you can connect all your devices. So if you take a look on my factory, I have a couple of devices connected, but the one we will work today is this Nairo UK lab. And as you can see here, it's connected to my factory. I can see which application is running. I can see which tag is falling for updates. I can see the IP. I can have many informations from my device. And okay, so now that we have the device, let me move further. What I'm going to do here is I will connect it to this device that is in the UK over WireGuard VPN. So first I'm connecting to a VPN. Now I'm in the server, and in the server I have this device connected over WireGuard. So I'm connecting to my Raspberry Pi that's inside my robot right now. Inside
the Nairo. Can you show us a little bit the Nairo so the people has a picture of what we are seeing here?
This is the Nairo. Okay. This is in the UK right now. It's right there without doing anything because we are not moving it. But the cool thing is this image is also streaming from the Linux micro platform. I put another container that just is streaming image, and I will show you in a second. I will leave it here for. I don't know if I can do something like that.
Okay, not possible. It's okay. We cannot see it now, but it's okay.
Let me.
Okay.
Yeah, I will do it this way and this way. Yeah, I will just move to the terminal. So
okay, great.
Let me. Can you see my terminal right now?
Yes, we can. Yes.
So if we take a look on this distribution, and what I'm going to do is just show my Linux micro platform. Like I said before, it's a very optimized distribution. It's mostly read only. You can do incremental updates for this platform. And you don't have all the programs like in Ubuntu. It's a very optimized. You don't have, for example, if I don't want to try cur, there is no cur. You just have wget, and you have to work with what we have.
Okay.
And you need something special, you can deploy containers here. So I'm looking to the containers, all the containers I have. The gray one is the robot. So what I have here is a Nairo robot with a Ubuntu and ROS. Mm-hmm. I have a Ray streamer container, which is doing the streamer that I just show you.
Yes, here on the image of the robot.
On the image, so this image is running, it's coming from this container, and we have a camera connected to the robot over USB. Mm-hmm. And then I also have an AWS IoT SDK that I'm sending data as CPU and run to the AWS cloud. So if we take a look in this graphic here, this gray one is my robot sending CPU and run to my AWS. And finally, let's move this robot. So what I'm going to do right now is I will put it back here. Just move it a little bit. So what I'm going to do right now is I will take a look on the logs inside the ROS container for us to see that it's a real ROS application running and all the logs and so on and so forth. So if, oh, just a second, I did something wrong. Docker logs and the name of the container. And as you can see, there is a couple of errors, but because I was connecting, it's connecting. But as you can see here, it's a ROS stack going up and down.
Okay.
And to connect it to the ROS robot, I will do a tunneling over SSH to my robot. So I need to hit this port 9090 to be able to connect. And I will use the WireGuard server to be able to connect there as well.
Okay.
So I'm just run this command, and now I'm going to open this Nairo Studio, which is the software that Nairo offers you to connect and control your robot. And now, because I did this tunneling, I have to reach my local host, and by doing that, I will be able to connect it in the robot. And as we can see here, it's a new client. I just got the log. They asked me for an update. I don't need to update it right now. And now we can see the robot, and it's the same robot that we are looking in this camera in the same position.
Exactly. So it's kind of R-based system that is showing us the current situation of the robot.
And what I did right now is I moved the robot here. We can see in the simulation. And we will be able to see also in the camera in a couple of seconds, because there is a little delay. We will see the same movement happening here in the camera as well.
Okay, yeah, so, exactly.
Yes.
We captured that. And so what happened is that you use this graphical tool to move the robot, the joints, and then we saw on the R-based capture of the status, the final position. Now those commands are sent to the real robot in the UK and then now they are executed. So as we can see right now. Yeah.
And like just one more thing that if you allow me is
sure.
we can disable and enable applications all the time. So for example, here is my PC. What I'm going to do is, like I said, we are running Nairo, we are running Ray Streamer, and we are running AWS IoT SDK. So I can also, let's say, disable the AWS. From my PC, I'm sending the command for this robot in the UK that I don't want to run this application anymore. And if we come back here in the Nairo robot and do like journal, we can see the actualizer light, which is the daemon responsible for updating and manage all these containers. He received a command and he will now disable this IoT AWS and will stop the IoT. And the cool thing is we can disable containers without stop other ones. So the ROS is still working and you can like having different modules, and that's really cool about our platform as well.
Yeah, because you can on the spot you can decide what can be running and what cannot. Just because, let's say, so for example, there is a feature in your robot, and then there has been discovered a very, very dangerous security break, and then you don't have the time yet to deploy some solution for that, but then you can go and stop the container which is affected. So that functionality is not available on the robot, but then you don't have this problem of being hijacked, your robot.
So the command I sent already finished. So now if we take a look again on Docker PS, there is no AWS anymore. there are just Nairo and Restreamer, and it's the same with the ROS and Restreamer or with any application that you create.
Okay.
So that's the demo. That's
great.
It's not a good. It's a fancy demo. We just are controlling a robot, but there is a lot of work behind.
Yeah, exactly. Well, you don't have to explain because the ROS developers there and the audience, they know how difficult it is to do something that works, and that's the way of showing. So come in here and doing a demo live, and then you see that this is working and it's not just a video posted somewhere. So it's a live demo that the system is actually running. So so I think it's cool. Thank you very much, Raul. Can we switch back to the camera so we can?
Yeah, I disabled the screen already. So now you can see myself, right?
Wait a second. No, wait a second. It's because this update. Okay, yeah. So we have this problem of it's not getting proper update for the recording. So let me put it back again in the proper dimensions. That's it. Okay, so thank you very much. Amazing demonstration, and so you have been controlling the robot there in the UK from Brazil, and doing live changes on the robot that is there, and you have demonstrated how it works. And so now we have understood about this problem in embedded systems and how we can take advantage of that for other embedded systems in our robots. That's what we are interested here, basically, in the ROS Developers podcast. So thank you very much, Raul.
I'm the one who need to say thank you because it's a really great opportunity for me that came from IoT and edge device industry to also hit the ROS developers community. So I'm really, really grateful for the opportunity. I'm really thankful. Okay,
our pleasure here, and I hope that we'll see each other more often in the communities there, interchanging information and comments and opinions and so on. Thank you very much, Raul.
Okay, thank you. Bye-bye.
And now to all the people out there, to all the ROS developers that are listening to here, so this is the end of this podcast. What I would like to tell you is that please help us get more audience to this podcast. So if you like it, comment tell it to your friends, tell it to your colleagues, share this in your Twitter account and so on, put a like and so on. So you will help us to increase the audience, that we want to reach more people and provide this interesting information to everyone. And that's all for today. So let's see you next week with another interview of an expert in ROS. And until then, keep pushing your ROS learning.